Good morning. Today we're going to start lesson 4-1 from your textbook, Savvas textbook. It's a continuation of what we did yesterday. We're going to solve equations by graphing, but today we're going to incorporate into our math a little bit of Desmos. And sometimes the problems are a little bit more challenging than the ones from yesterday. So let's get started with the warm-up here. First of all, this is Juan and Leo. We're supposed to meet and drive ATVs on the trail together. Juan's late, so we started without him. So here's Leo. Obviously they're going on a trail and it's 40 miles long. Leo's going 12 miles an hour, but Juan's going 15, so he's going to catch up to him sooner or later because he's going 3 miles an hour faster. So he's trying to catch up to him. 3 miles per hour is not that much of a let's catch up to Leo, but it's still faster. So you need to write an equation for Leo, distance from the starting point after writing X hours. Slope and speed are kind of the same thing. If he's going 12 miles an hour, it should be an easy equation to write. Juan's a little bit harder though because he's going 15 miles an hour, but we have this little problem that he starts from a starting point if he starts H hours after Leo. So they're kind of giving you a little bit of a clue with this word after here. So do your best. Try to write your two equations. Write one for Leo and then write one for Juan. UAN. And do your best. Let's see. And then let's answer these other questions here real quick. Suppose H is 1, because that's going to be 1. He's starting 1 hour. How can you graph the two equations to determine who finishes first? How can you use graphs? So if we graph both of these equations up here, how would we know, when somebody got to 40 miles down the trail first? And so just give me a sentence there. And then how much of a head start must Leo have to finish the trail at the same time as Juan? A lot of kids skip these because they require some higher thinking here. But do your best shot, and then you can at least think it through. And then we'll look at my answer and how I approached it. There's a couple ways that you could approach this, but I'll show you the one of the way that I did. All right, so pause your video. Give these guys your best shot. Okay, so here's Leo's equation for me. He's going at 12 miles an hour, so we don't know how many miles he's traveling, so his equation is going to be y equals 12x. Juan, this is the part after Leo, minus 15, because he's going 15 miles per hour, and so if he's going 1 hour less or something like that, that means, there's the 1 hour less. Alright, so he's going 15 miles per hour, and minus 15. If I had to graph both of these guys, well, all I would do is look at my equations and see who hits on the y-axis at 40 first. Okay, they're going at different slopes. So again, this guy's going to be a little bit steeper, but I want to see who gets to 40 first. So down here, because they said, he had a head start, how much of a head start? I just went with the two equations without the minus 15h, meaning he started 1 hour behind. So what I did is I said, okay, he's got 40 miles to go. Let's see how long it's going to take him to go 40 miles. And he got 3 1/3 hours. Then Juan, he starts and he goes 40 miles at 15 miles an hour, so it took him 2 2/3 hours to do the 40 miles. So what I did then is I subtracted the two. I found out the difference between the two because I want to know when they're both going to get there at the same time. So I subtracted the two and I got 2/3 of an hour. So that's why units are important, because this is miles per hour. Well, that's 2/3 of an hour, so I needed to know what 2/3 of an hour was. So I multiplied it by 60 and I got 40 miles, or 40 minutes, sorry. So he needs a 40-minute head start. Anything more than that, Leo's going to get there first. Okay. Anything after that, one's going to catch up to him and then ride the last little part of the trail together. But to get there at the same time, you can start 40 minutes after. All right. So I hope that helped you there. We already talked about this yesterday, that the solution to the equations is where two lines intersect. We're going to go a little bit deeper into the three different kinds that you can have one solution. You can have no solution, or infinitely many solutions. We talked about this yesterday and reviewed it. And so they're going to start us off like we haven't done this, but we did do it yesterday. And so what they did is they just graphed these two guys, but we have a little bit more challenging ones to graph here. Not too terribly bad. So you're like 6 is your y-intercept, positive slope, you're going to go up a half over 2. Here we have a negative 4. I got graph paper for you on today's math problems. And we're going to go down 2 over 2. So we're going to get these guys graphed. We're going to see the exact point where these two guys cross, and then from time to time we're going to check our answers. And so let's go check it real quick. My y is a 4, so it goes over here. Minus 2, negative 4, minus 4. Well, that's 8 positive minus 4, and it works in the first one. Okay. At some point we hope these become a little bit of a mental math problem. I got 0.5 times negative 4. I don't know where my digital. That's a negative 4. Plus 6. Well, I know half of 4 is 2. Positive times negative is negative, so that's a negative 2 plus 6. And I got 4 equals 4 as well. So this is a very good way, as I mentioned yesterday. This is probably the last chapter test that we'll have before Christmas. And so some kids are really needing to enhance their grade or bring their grade up. And so it only takes a minute to check to make sure that that's a real solution there. So I would highly encourage it, and a lot of times it is mental math to check these guys. Most kids can say, hey, the 4 goes there. I know negative 2 times negative 4 is a positive 8. 8 minus 4, good, okay, in their head. So this has exactly one solution, just like we mentioned up here. Now what is important, as we discussed yesterday, the slopes are different. So that's what I'm going to look for, because a lot of times we can speed things up. They're going to say, hey, is there one solution, no solution, or infinitely many solutions? And so if I look at the two equations in slope-intercept form, and then my slopes are different, and then my y-intercepts are also different, then it's going to be one solution. So sometimes that's what all they want to know. They don't even care about what the solution is. They just want to know if it's one solution, no solution, or infinitely many solutions. Okay? All right. So you got 2 here to do. We had a mistake on the notes here that was different from the textbook, and so whoever made up the PowerPoint had a -7. I think yours says -7 here. Yeah, change that to a +1. All right. So pause your video, graph these two guys. That one's already in slope-intercept form. Both of these are in slope-intercept form, so it should be a pretty quick graph. Graph both of those guys and show your solution. You might check your answer on answer B here, okay? Because just like yesterday's homework, we're going to check from time to time. All right, pause your video. Come back when you're done. All right, we got some nice whole numbers here. I got 2, -1 for the first one, and -4, 2 for the second one. A lot of times the biggest mistake kids make on here is they get the slopes wrong. So before I just look at my slopes and say, you know what, it's positive slopes. When I draw that guy, I make sure that I have a positive slope. And then the second one, positive slope as well. So both of these guys have a positive slope. Over here, my red one is a positive slope. There it is. And then also on that red one, it's like, well, I don't even have 10 on my graph paper. So just like we discussed yesterday, sometimes you have to make a little table over here to get some numbers on the graph. That's just what you got to do. Okay, just don't sit there and say, man, let's change the scale on this guy. That's why they teach tables first. They always work. They take a little bit of thinking and a little bit of extra time, but I gotta get that graph on there. Okay, my y-intercept of 10 is not on that graph. So plan B, what are we going to do? Okay, all right, back to this, but this is a negative slope, so I have a negative slope here, and so that's the biggest mistake kids make. especially if their answer doesn't check out and work, is check your slopes, okay? I checked mine real quick over here, plugged it in, showed my work here, and they both worked. Over here, if I put a -1 in for that in mental math, I know half of 2 is 1. So I put in a 2 right there. Half of 2 is 1. 1 minus 2 is -1. So mental math. I want to put the -1 here. I want to put a 2 here. 3 times 2 is 6. 6 take away 7 is -1. So mental math comes into play here on checking your answers before you go on, okay, or hit enter on your computer. All right. Let's talk about infinitely many. We discussed this one yesterday, but again, we have to have a plan. You know, this guy's in standard form. I can find my y-intercept very quickly by putting a 0 in here and divide both sides by 5. I know my y-intercept is going to be a 5. And so I could come over here and put a dot on 5 right there. But when I do for my x-intercept and put a 0 in for the y and make him go away, I want to divide both sides by 15. Well, 25 divided by 15 is not a nice number. So best strategy is to take that 15x plus 5y equals 25 and get it into slope-intercept form. Would you please do that? So I see my y-intercept is a plus 5, but I already knew that. So I needed my slope. So it's a negative slope. It's a -3 over 1. So I go down 1, 2, 3 over 1. 1, 2, 3 over 1 and draw my line. So there was my first equation. So a lot of times I'll put a box around it once it's in slope-intercept form. Now this guy almost is in slope-intercept form. All we have a problem of is this is written backwards. So I have y equals -3x, if I put them in order, plus 5. I have the exact same formula here. -3x plus 5. So I put a dot on 5. Down 3 over 1, down 3 over 1, and I have a line on top of a line, which means infinite solutions. Okay, so on infinite solutions, I'm going to put a star here, is when the slopes are the same. And y-intercepts are the same. Then I have infinitely many solutions. Any line or any point on that line will work in both of these equations. If you wanted to check, pick a nice easy one like this one, 1, 2. So 2 goes there, the 1 goes for the x. -3 times 1 is -3. -3 plus 5 is 2. I want to check it over here. 2 goes there, 1 goes, well, I don't have to, they're the exact same question, so silly me. Alright, you're probably yelling at me, dude, they're both the same. Alright, so infinitely many. So sometimes when a kid sees this graph here, they'll say, well, where's the other line? There should be 2 lines. I see 2 equations there. Well, again, your clue, just like not thinking me a minute ago, it's a line on top of a line. So there is only going to look like there's one line. Okay? Alright, let's carry on here. I'm looking at my first equation. It's not in slope-intercept form, but now I'm going to kind of do some things mentally. Just be careful. If I got that x to the other side, I would add 2 x's to both sides. So now that we're older and we can do some of the mental math, if it's only like one step to get it over there, I'm just going to do it mentally because I want to be about speed. Okay? I see it's a positive slope, so let's go put a dot on 6. I can't go up 2 over 1 because I'm off the graph, so I'm going to go down 2 over 1, down 2 over 1, and draw my graph. Just like yesterday, it's a good habit to write your equation on there, on the end, so you know who's who. So I want to write it here, y equals 2x plus 6. I want to go do this guy. This guy's in standard form, so before I go put him in slope-intercept form, I want to see if I can do it just by standard. If I put a 0 in for this guy, I would divide both sides by 2, so my y-intercept is going to be a 4. That works. I can get him on there. And then if I put an x or 0 in for the y, I can find the x-intercept by dividing both sides by -4, which would be a -2. So I'm going to graph this guy by using standard form. And it's looking like those guys might be parallel to each other. So if I'm not sure, I'm going to go over there and see. It's a little bit off on my graph there. It's a little hard. So I want to put this guy into slope-intercept form and see if these two guys are the same. I'm pretty sure they are. So get that x over to the other side. And get rid of that 2. And look, they are both the same. So if I have slopes that are the same, but different y-intercepts, that's going to be parallel lines. So I'm going to put a note over here. No solution is if I have same slopes, but different y-intercepts. Okay, so that's kind of the rule there. So down here for our solution, there is no solution. There is never going to be a place where those guys cross. That's what no solution means. Alright, you got 2 to try here. Get those guys out of the way. So pause your video and come up with your answers. Let's see how you did. Okay. I got no solution for the first one there. I had a y-intercept of 7, and we talked about this yesterday. You can go off the graph by 1, but you can't go off any more than 1. Even if it was 2, you know, you could do your slope and get yourself back on the graph fairly accurately, but at least I need 2 dots on the graph. Okay, so you can kind of cheat a little bit. I got no solution there, and over here I got infinitely many solutions. Let's see where my equations are. There's 1, -3/2 plus 4.5, and here's my first equation when I got it in the slope-intercept form. A lot of times, you know, unless it's standard form, if it's in point-slope form, I just get them all into slope-intercept form. It only takes 2 steps usually, and then I can compare the slopes, and then I can compare the y-intercepts as well. And so I was always taught slope-intercept form. Just get them all in slope-intercept form. I don't think I even remember doing point-slope form when I was in school. We just did standard form and slope-intercept form. All right. Here's our word problem for the day. Monisha and her five of her friends want to attend a concert. They're trying to decide whether to buy the tickets online in advance or at the ticket booth at the day of the concert. So let's just look. If you buy them in advance, it's $62, and that's usually how it is. It's cheaper if you buy them in advance. But look, they have a one-time service fee because they're using it online. A lot of times these are businesses out there that sell the tickets for whoever the concert's for, and so they get paid by these fees here. Now if you go to the door and buy them, they're usually a little bit more, and so it's $67. And so this is kind of interesting. They have $400 to buy the tickets. For a number of tickets will the cost be the same? So that's a big problem right there, is I want to know when they're going to be the same, whether they buy them at the door or in advance. Which way will it cost less for all 5 friends to attend? So one of the biggest mistakes kids make is when they're talking about friends, they'll put a 5 in because they see the 5 here, but it's Monisha and 5 friends. So first of all, kind of focus in on how many people are going. There's really 6 people. A lot of times they see the 5 friends, the 5 up here, they just put a 5 in. Okay, So let's go write our two equations here. What system's equation represents the concert tickets both online and in person? Well, why do they have Monisha and Holly here? Let's write our two equations here. So y equals, this guy's $62 per ticket, and they have an $18 service charge. Okay, and I'm not sure why they have two girls' names here. Are they buying them different? Huh, I don't understand that. Anyhow, let's just move on. Let's write the two equations, because that's what they say, right? Is a system of equations. Let's go with this guy over here. We got y equals just 67x. There's no service fee, so it's just plus 0, or just leave it like that. Okay? So now what we're going to do is we're going to go to Desmos. Let's open Desmos and put these two guys in and solve it by using some technology here. Alright, it's going to take me a little to get it up here. I usually have it ready, but look, I've been using it yesterday, so I'm just going to do this quick. Pull up Desmos on your calculator, or on your computer. It's in your Clever account. Desmos is a very nice free calculator, graphing calculator. Up here it's already set up for equations. Now, you don't need, most of Desmos and graphing calculators, you don't need to put the y equals, but you do have to have it in slope-intercept form. Okay, so we're not going to put y equals 62 plus x. We're just going to start out putting 62x plus 18. And it's going to give us the graph right there. Boom. Now, notice a couple things. They already have the x-intercept right there. It's a decimal. That'd be really hard to transfer over a negative 2.9. Well, yeah, it'd be really hard. Okay, and somewhere up there, they have the y-intercept too, and usually they'll put a dot or something near it. I'm not seeing a dot. Might be right there. Alright, let's go put in the other equation. You just click on the box below it, and we're going to put in 67x. And now I got my other graph. Now, if we zoom in, a lot of times they'll tell us, they'll put a dot because they know you're looking for where they're going to be the same. Oh, here it is, 18, 0, 18, I saw it earlier. So you got to look for the dot. There it is. So 18 is where they intersect. But we need that, no, that's the y-intercept. Sorry. That's what I was looking for. We're looking for where these guys, oh great, we're looking for where they cross or intersect. So let's see where we're at here. It's going to be like way up here, I believe. No, way down here. They must have already crossed. Sorry. I got ahead of myself here. What's the deal here? I'm not seeing where they cross at. Oh, I'm in the negatives. Good Lord. Let's get up to 0. There's 0. Holy cow. Alright. Something's wrong here. Something's wrong. What do I got over here? I got 62x plus 18. 18 was my y-intercept. 67x. So that guy is blue. My 0. That would be true. Eventually I should catch up here. My land. Alright. I'm just going to keep following here. It's going to be up here quite a ways. Oh my goodness. Getting close. They're almost on top of each other. There should be a dot where they cross, because they say you're kind of looking for the point where they cross. They know that, so I'm kind of looking for a dot. Man, up there it just showed up. I just zoomed in, zoomed out, all of a sudden it showed up. Boom, there it is right there. So I don't know what I just did there, but there's my dot where they cross. So I want to record that on my paper. I got 3.6, 241.2. So my solution was 3.6 and 241.2. So this is my ticket number, 3.6 and 242.2 is my ticket number. So they intersect. I'm just going to draw an arrow here because they said my solution. The price of 3.6 tickets is 241.2. That's where they're going to cross. So if they buy tickets at the door, they will cost, so let's go find it. At the door, they're going to buy 6 tickets, I believe it was. So let's do 6 times. That's when they're going to cost the same. If they buy the tickets at the door, I want to use the equation y equals 62x plus 18. Let's put a 62 times 6 in there. This is an 18. Let's do that math quick. And we're buying 6 tickets plus 18. I think what they want us to do, 241 times 6, I think is what they want us to do. .2 times 6. Now that's 3.6 tickets. If they buy tickets at the door, they will cost. I got $62, 6 tickets, $18 service fee. So let's try that again. 62 times 6 plus 18. I'm getting $390. If they buy the tickets at the, that's this guy down here. If they buy them online, okay, I have them backwards. I was going to say, something's not right here. And if they bought them at the door, that would be the y equals 67x. So I'm going to put a 6 in, so 67 times 6 would be $402. Man, I'm getting a lot of 4s here. That 4 just doesn't like, I don't know, what was it? $402. Now, something I just thought about earlier up there in the problem, they said they only have $400 to spend, I believe. So they might be constrained here to, yeah, they only have $400. So that's a constraint there. Oh yeah, down here it's cheaper for them to buy tickets online. And then not only that, they only have $400, so they have to buy the tickets online. Because they only have $400, so they don't even have a choice to go buy them at the door. Okay, all right. So I'm just trying to look. They bought 3.6 tickets. It would be 241. That's where they're going to cross. I'm not sure why they asked us at what point will they cross, other than just can we get them in on our graphing calculator and see where they cross there. All right, because I'm not trying to find out where they'd be the same. So that was kind of interesting. I think they were just getting us used to Desmos there. All right, let's see what we got here. 2 friends realize they're not able to attend the concert. Is there still a better buy of the 2 tickets in advance? What's the difference in the price ticket? All right, so we're still going to use those two equations there that you had earlier. I think it was $62 plus 18 was the online one, and I think the other one was just $67. So don't need any graphing. Find out how much these tickets are. 2 friends less came. All right, pause your video, come up with that, and don't forget to do what's the difference in the price ticket. Usually it's pretty close to being the same. All right, let's see how you did. Here's my online work. I got $266. At the door it was $268, so online is cheaper at this point, and it's only $2 cheaper. Okay, so you have to say which one's cheaper, and then also how much cheaper. Sometimes if it's a small amount of the difference, it's like, hey, if it's only a couple bucks, big deal. It's a big inconvenience. I know I'll have my ticket secured or whatever. That sometimes people weigh that. Maybe pay a little bit more, but for convenience. All right, let's go. I think we're about done. Nope, we got one more Desmos one here. All right, both of these guys are in your graphing calculator, and they want us to find a point of intersection, and then they want us to check the two once we have the answer. All right, so let's go to Desmos. Let's clear those guys out and put in our two new equations. To get rid of them, just hit the X just like we've been doing. And they're already in slope-intercept form, so just make sure you get them in there right. It seemed to me, and you're probably going to yell at me, that there was a feature in Desmos, and we might go look for it, that will tell you where these two guys intersect here. Let me get rid of this here. Maybe it's some of these options down there. Nope, that's my video recording tool. Alright, well I'm way up there on my graph paper, so I need to find out where these guys are. There we go. Now I can see where they are, and if you zoom in and I click on it, I can see my intercepts right there, and then I can see my solution right there. Right there is where they cross. I got 1.28. Now normally, again, we round to the hundredths place. We're rounding, so we're going to do, when we do our checking, it's going to be an estimate. So 8 is in the hundredths place. There's a 5 next door, so that guy's going to become 1.29. So go record that for your X. 1.29. Oops. And let's go get our Y. It's a negative 0.43. There's an 8 next door, pushes the 2 up to a 3, so negative 0.43. Alright, so we got those. Now, when we do our checking down here, it should be pretty close. In the back of our head, we're going to say, hey, you know what? I did some rounding there. The more digits you have, the closer your answers are going to be. But when I'm done checking here, it should be pretty close. Alright, do some math and let's check it. I got negative 0.42 on this side, and over here I had 0.43. And we're 1/100th off. But again, we did some rounding, so what you usually do is, whoops, you put an estimate here. An estimate is a wavy equal sign like this, so that people know that you did some rounding here. Alright, let's go check it on this guy over here. Negative 0.43 was my Y. 1.29 was my X. Alright, let's check that guy out. And then if I add 6 to that, I get a negative 0.45. Over here I had negative 0.43, so I'm 2/100ths off on this one, but they're pretty close. So it's a little bit harder to check your answer for accuracy here. But we're pretty close, so we're pretty confident. Not only that, we had a graphing calculator tell us what the answer was. Okay, so big takeaway today is the system has one solution if the slopes are different and the y-intercepts are different. Over here, I would continue to get that guy into slope-intercept form by dividing by 2. And then I'd have a y equals minus x plus 9, which my slopes are the same, and my y-intercepts are the same. Over here, no solution is when my y-intercepts are, my slopes are the same, but my y-intercepts are different. That means it crosses the y-axis at different places, but my slopes are going to be the same. So, 3 different possible answers on systems of equations. We're still just dealing with 2 equations. Eventually here, we'll get 3 lines on there, and we'll be looking for where 3 of them cross, okay? All right, it looks like that's it for today. So hope to see you tomorrow. It's an online Savvas lesson today, so go online and do your homework. Have a good day.